Hello guys, myself Swapnil sir, your best mathematics teacher, and I'm welcoming you all to yet another video on our channel. Already we have started lecture series based on the different topic from mathematics, which completely rely or depend on your coming SPI exam. So if you are interested to see this video, do check in my playlist. So in my today's video, I'm going to explain to you all, first of all, important concept related to the mensuration, trick some of the concept that you can remember for your exam, and then at the end we go for solving some of the important exam which will be very much important for your upcoming SPI exam. As we all are aware about that SPI exam nearly asking 20 to 25 question based on mensuration chapter. So mensuration chapter, it is one of the easier chapter in mathematics, but as we know, most of the students found it difficult because they are complex formulas, complicated concept to understand. But in actual, what we have in mathematics, those concepts we found it difficult. Here that actually not that difficult. These are the one of the easy concept in our mathematics. So without further ado, let's get dive into our today's lecture. First of all, I'm going to explain to you all the formulas in simple language. Then we go for some of the trick that you can remember this formula for while your exam there. Okay, and at the end we solve some of the example based on this formula, because all these formulas and example are going to important for your upcoming SPI exam. So let's get start our today's lecture. First of all, this one is our next lecture based on the mensuration. Already I have uploaded one more video based on the mensuration. You do check in my playlist. Okay, so let's get start our today's lecture. Okay, so first of all, before we start our mensuration chapter, I have to explain to you all what actually we are going to learn in a mensuration chapter, or what I taught in my previous lecture. Okay, so mensuration chapter, which is mainly divided into the two part. Okay, which is one is for the plane figure, another it goes for the solid figure. Okay, plane figure and solid figure, these are the two the major part of the mensuration. Okay, so plane figure means the figure which we can see only one side by our eyes. Okay, now we can see if we consider a triangle, if we consider a circle, if we consider parallelogram, we can see only a front side or a single side of that shape or figure. So that comes under a plane figure. Okay, but when it goes to the solid figure, that means solid figure means it is having some solid shape. Okay, solid shape means we can see three sides of that solid shape. Okay, how many sides we can see it here? Total number of, we can see three sides, then we consider it as the solid shape. Okay, now what are the major solid shape we all are familiar till moment? Okay, first it is a cone. Okay, like a cylinder, cone, sphere, hemisphere, cube and cuboid. Okay, these are the major solid shapes which are very much important in your SPI exam. Consider that based on this solid shape, you will get near about 13 to 15 example. How many example? 13 to 15 example in your SPI exam. Okay, so make sure that you all have to understand these formulas first. Solve more example, you can get this concept very well. Okay, yes. Okay, let me start this concept step by step. I will explain each and every point. Okay, each and every point with their formulas. Okay, so first of all, we go for the volume of our solid shape. After that, we go for the curved surface area or lateral surface area of our solid shape. Okay, and at the end, we go for the total combine, which is a total surface area for our solid shape. Okay, these are the major part here in our solid shape. But as we go for the plane figure, we need to understand for the plane figure there is a circumference, area, perimeter, okay, diagonal. These types of the concepts are coming in a plane figure. Okay, that you all have to understand it. Okay, so we go for understanding all these concept detail. Okay, let me write what are the major part we are going to understand it here. Okay, Which one? First it goes for the plane figure, okay? Plane figure, okay? And second it goes for the solid figure, okay? First it goes for the plane figure and second it goes for the solid figure, okay? Now under plane figure we are going to learn the concept related to the perimeter, area of a triangle, area of any plane figure, okay? That triangle already it is the part of a plane figure, okay? So first we are going to understand here it in plane figure, which is the area. Second we go for the circumference. Third we go for the, after that, area, circumference, perimeter, okay? Perimeter, okay? All these concepts are there and maybe you will get more concept related to the plane figure, okay? That all the properties you have to aware about it, okay? These are very much easier that you can remember, okay? Now main part it goes for the solid figure, okay? So which concept we are going to deal under solid figure, okay? So first it goes for the volume of our solid figure. Second it goes for the lateral surface area or curved surface area, okay? Lateral surface area or curved surface area, okay? Actually, what is the difference between lateral and curve? Both are having same meaning, okay? In our three-dimensional figure, like a solid figure, lateral surface area and curved surface area both are equal, okay? Always remember this one. Okay, now after that, lateral and curved surface area, we know that the total surface area, it is also part. Total surface area, okay? Again we have a total surface area. These are the concepts just generally we are going to deal it here in our today's lecture, okay? And all are the important, okay? In perspective of your upcoming SPI exam, okay? Now how many questions are important here? Like 14 to 15 question. At least you will get the 14 to 15 at least. That means see that how many questions are possible based on these mensuration concepts, okay? So you have to be a really much perfect in these concepts, okay? We don't have to lose these easy marks, okay? And I will explain to you all which type of the questions are coming in our today's lecture, okay? Yes, let's go for understanding, okay? You all are already familiar with the circle, triangle, parallelogram, okay, like a rhombus, kite, all the shapes you are already familiar. You are learning all these concepts from your 7th, 8th standard, okay? But the 3D shapes, like a solid shape, cube, cuboid, cylinder, cone, sphere, hemisphere, these are little new for you all, okay? I will explain all of them to here right now, okay? Just first of all, let me get a little overview about the plane figure. Okay, we know that the triangle, okay, triangle. So with respect to triangle, we need to know area of a triangle, okay. So if we consider our plane triangle, then area of a triangle is 1/2 into base into height, okay. This one is our area of a triangle, okay. And when we go for area of a equilateral triangle, okay, area of equilateral triangle, which we write √3 divided by 4 side square, okay, equilateral triangle, okay. For equilateral triangle, we write √3 by 4 into side square. Area of a triangle we write 1/2 into base into height, okay. Just for your regular triangle, we consider area of a triangle is 1/2 into base into height, okay. About equilateral triangle, we consider √3 by 4 into side square, okay. And about isoscale triangle, okay, about isoscale triangle, we consider area of a triangle as a base divided by 4 under square root 4 times one side square minus base square. Okay, that means equal side square minus base square. If we have isoscale triangle, okay, then we write we are looking only for the area of a or different type of the triangle. Okay, you need to understand it. Okay, area of a isoscale triangle, we write base divided by 4. Okay, base divided by 4 under square root. Okay, isoscale triangle means we have two sides are equal. Okay, two sides are equal, and base it is a different than these two sides. Okay, then we write base divided by 4 under square root equal side square minus base square. Okay, equal side bracket square minus base bracket square. Okay, this one is the area of our different triangles. Okay, and area of a circle, which is a pi r square, you are already familiar about area of a circle, pi r square. Okay, after that area of a semicircle, that means if we cut circle into the two equal part. Okay, if you have circle, if we cut this circle into two equal part, we get area of a semicircle, which is the we get the semicircle, and area of a semicircle means half of a area of a circle, which is 1/2 of pi r square. Okay, this one is the area of a semicircle. Okay, okay, circumference of a circle, which is a 2 pi r. Okay, that's it, we need it here. Okay, now let's move for the some 3D shapes. Okay, different formula for our solid shapes. Okay, let me explain with the solid shape. Let me explain with the solid shapes. Which solid shapes generally we are going to learn it here in our today's lecture. Okay, so first solid shape, we take it to the cylinder, then we go for the cone, sphere, hemisphere, cube and cuboid. Okay, all this solid shape we need to understand it here. Okay, so let's get start our first solid shape. It is a cylinder. Okay, yes, what we have for solid shape? It is a cylinder. Okay, cylinder. Okay, now what do you know about cylinder? Okay, let me make one figure for you all. Okay, what actually mean by solid shape, solid our cylinder. Okay, solid cylinder. Okay, we know that our cylinder, it look like this way. Okay, this one is our cylinder. Okay, let me plot it again. Okay, this one is our cylinder. Okay, this one is the height of our cylinder, this one is the radius of our cylinder. Okay, consider that I given one cylinder here for you all. Okay, now see that with respect to cylinder, we have to understand the concept, which is the volume of a cylinder. Second, curved surface area or lateral surface area of a cylinder. Okay, third, total surface area. That's it, the concept here. Okay, now see that I built one cylinder for you all. Okay, you can understand this look like a cylinder. Okay, cylindrical shape. See that all around here we have curved surface area or lateral surface area from outside. Inside part we call it as the volume. Okay, that means how much space we do have inside that cylinder, we call it as the volume. Okay, that means inside part it goes for the volume of a cylinder. Okay, that means how much water we can pour inside that cylinder, or how much space we do have inside that cylinder. Okay, yes. After that, total surface area means area of a top, area of a bottom, plus all the area of our curved or lateral surface area. So all it comes under total surface area, curved surface area, lateral surface area, and volume of our cylinder. Okay. Now let me explain how can we remember all these formula for our lifelong, because these formulas maybe it is quite bit confusing to you all. As I come to understand, most of the students, they found all these formulas are quite difficult to remember or understand. Okay, but let me explain to you all short way that you can remember this formula for your lifelong. Okay, so what do you need to know? Just you need to know everything about circle, like a area of a circle pi r square, and after that circumference of a circle 2 pi r. Okay, once you come to understand these two concepts, then all the solid part of the our shapes are easier. Okay, yes, let me write area of a circle. What is the area of a circle, which is the pi r square? Okay, what we have area of a circle, which is a pi r square here. Okay, now see that circle, it look like this way. Okay, because the circle, it is a plane figure, that means it do not have any kind of height. Okay, if any circle gets height, it goes to the solid shape. Okay, now see that consider a coin that you all are already know that the coin. Okay, 1 rupees coin. Consider a coin. We are going to take complete 20 coins together. Okay, so if we place all the coin together, now we can see we get the one sort of a condition extra, which is a height. Okay, now what we do, we put n number of the coin on coin like this way. Okay, now we can see it here. Okay, we can see it here. We got the cylinder. Okay, we got the cylindrical shape. Okay, what we got here, cylindrical shape, but extra what we found here, which is a height only. Okay, from circle to cylinder, when we place coin on coin, we get the extra only one condition, which is the height. Okay, so height, it is an extra factor there. So if I'm going to add height to the area of a circle, we get the volume of cylinder. Okay, what actually area means? Area means, now we can see it is circle, the inside, complete inside part of that circle, we write the area of a circle. Okay, complete inside part, which is the area of a circle. But in the case of a 3D figure, okay, in the case of a 3D figure, that area goes to the volume. Okay, in the plane figure, it is the area. In the solid figure, it gets into the volume. Okay, these are the major difference between plane and solid shapes. You need to understand. Okay, yes, so we got the extra height with the area of a circle, then we get the volume of a cylinder. Okay, now let me write volume of cylinder. Volume of a cylinder, we know that the area of a circle, which is a pi r square. Okay, but we got the one extra factor. Okay, what is the extra factor? We have here height. Okay, height, which is the extra factor in our area of a circle, then we get the cylinder. Okay, I hope you all have understood the meaning for volume of cylinder. Okay, how can we remember the volume of a cylinder, which is the area of a circle into some sort of a height? Okay, which is the volume of a cylinder. Okay, yes. Now what we do, now we want the total surface area, curved surface area. Okay, so curved surface area means the area which around that cylinder. Okay, so the area which around here, we consider the volume of cylinder, curved surface area or lateral surface area. Okay, so curved surface area oblique lateral surface area, which is the around part here. Okay, now a simple trick to remember this one, take that 2 front here and minus 1 it here. Okay, then we write a pi 2 pi r h. Okay, now we can see that I taken that 2 front here, and what I have done, I subtract 2 from 1 from that 2. Okay, So I got the 2 minus 1 as 1 here and 2 pi RH as the total or sorry curved surface area or lateral surface area for our cylinder. Okay, see that how easy it is. Okay, nothing it is difficult, just need to understand these tricks. Okay, now let me move for next part, which is the next part it goes for the total surface area. Okay, let me write total surface area. Okay, total surface area means we have to consider all around the part of our cylinder. All around part means area of a top, area of a bottom, all curved surface or lateral surface area. Everything together it goes for total surface area of our cylinder. Okay, now total surface area of our cylinder, we write area of a top. Area of a top means we have one circle at the top. Okay, area of a bottom, it is also the circle at the bottom. That means area of a top means area of a top circle, area of a bottom circle. So area of a top circle, which is a pi r square, area of a bottom circle, which is a pi r square, and a curved surface area, we know that 2 pi r h. Okay, 2 pi r h, which is the total curved surface area and lateral surface area. Now see that this one is our complete total surface area. So what we do, we make it into the short form that we can understand it easily. Okay, so pi r square plus pi r square, we write 2 times pi r square plus 2 pi r h. Okay, take 2 pi r common here, 2 pi r common, then under it remain here r plus h. Okay, this one is our total surface area for our cylinder. Okay, that's it for our cylinder. Okay, after that cylinder we have to go for the next part, cone. Okay, have you seen cone, everyone? Yeah, cone, we have seen cone plenty of the time, like a chocolate cone or like a birthday cap cone. Okay, so it is look like a cone. Okay, birthday cap. Okay, the birthday cap, it is also the shape of cone. Okay, yes. Now cone, it how it look like? It look like that cone this way. Okay, see that this one is the height, this one is the radius. Okay, this one is the cone here. Okay, now let me explain how can we remember all the formulas related to cone. Okay, as we learn for our cylinder. Okay, now see that this one is the cylinder. So how can we form cone using our cylinder? Okay, so if I take three cross section, that one first, that one second, that one third. Okay, if I cut three equal part, okay, of our cylinder, we get the three different of cone. Okay, three different cone. That means volume of a cone, okay, let me write volume of a cone means 1/3 part of a volume of cylinder. Okay, so what I have done, basically I have to take three equal part of our cylinder. Okay, that means we get the three different cone. Okay, and volume of a cylinder, which is a pi r square h, and we want the volume of a cone, that means 1/3 pi r square h. Okay, which is the third part of that cylinder, that is a 1/3, and the volume of a cylinder, which is the pi r square h. Now see that volume of a cone, how easy it is to remember. Okay, it is completely easier to understand. Okay, yes. Now curved surface area for our cone, which is a curved surface area. Now for our curved surface area, we don't have height, we have slant height. Okay, in the case of a curved surface area, we consider the slant height here. Okay, so slant height, which is a, we consider this one as a L. Okay, and then we write curved surface area, which is the pi r L. This one is our curved surface area for our cone, which is a pi r L here. Okay, yes. Now we want the total surface area, okay? Then total surface area. That means area of a top, area of a bottom, and total curved part of our cone. Okay, that's it for our total surface area for our cone. Okay, now what we do, we are going to add everything together. We'll get the total surface area. Okay, area of a top means we have one single dot. Okay, that means we cannot consider, because that do not have any area, so we cannot consider that area as the part of our cone. But at the part of a bottom side, we have circular shape. That means area of a circle, it comes from the bottom side, and the curved surface are lateral surface area. Okay, so area of a bottom, we have circle. That means area of a circle, which is the pi r square. Okay, curved surface area, lateral surface area, we write a pi r l. Okay, then take pi r common from here. Okay, then we write r plus l. Okay, this one is the total surface or total surface area for our cone. Okay, see that how easy it is to remember. Okay, now after that cone, we have a sphere, hemisphere. If we join 4 cone together, we get the sphere. Okay, sphere, it is look like a volleyball, football, these types of the figure, it comes under the sphere. Okay, yes. Now volume of a sphere means, which is the 4 times volume of a cone. Okay, we are joining 4 different cone, so we get the volume of a cone, volume of a sphere. Okay, so volume of a sphere, we write 4 by 3 pi r square h. Okay, yes, 4 by 3 pi r square h. Okay, and total surface area, curved surface area about a sphere, we have both are equal here. Okay, that means total surface, curved surface, both completely equal in the case of sphere. Okay, yes. Okay, then after that we have after that we can write about volume 4 by 3 pi r cube. Okay, 4 by 3 pi r cube is the volume of sphere. Okay, then total surface area of a cube, we write 4 pi r square. Okay, 4 pi r square, it is a total surface area for our sphere. Okay, yes, and a curved surface area, total surface area, both are equal. After sphere, we write, this one is for sphere. Okay, after that we write hemisphere. After that we write for hemisphere. Hemisphere means half of the sphere. Okay, hemisphere means what we write, hemisphere. Yes, hemisphere means if we have any volleyball or football like a spherical shape, we cut both into the equal part. Okay, if we cut that sphere into the equal part, we get the 2 hemisphere from one sphere. Okay, so we have to think about the hemisphere means we have to cut sphere into the 2 equal part. That means volume of a hemisphere, which is the 1/2 into this volume of a sphere, 1/2 into this sphere means 2 by 3 pi r cube. Okay, 2 by 3 pi r cube, which is the volume of a hemisphere. Okay, total curved surface area of a hemisphere, we write 2 pi r square. Okay, and total surface area of our hemisphere, which we write 3 pi r square. Okay, this one is for sphere and hemisphere. I have taken little bit faster at the end, because all these concept I taught it in my previous lecture. You can see it from there. Okay, yes. Now leftover part we have here, which is the cone, cube and cuboid. Okay, now let me explain one thing here. What is the difference between cube and what is the difference between cuboid? Okay, cube and cuboid. Let me write with one more here, cube and cuboid. Okay, let me write for cube and cuboid here. Okay, yes, in the case of a cuboid, length which not equal to breadth, which not equal to height. What I said, in the case of a cuboid, length which not equal to breadth, which not equal to height, then we consider it as the cuboid. Okay, length not equal to breadth, not equal to height. Okay, then we consider it is the cuboid. Okay, how the cuboid it look like? We can see this shape likes. We consider it as the cuboid. Okay, now see this one, we have cuboid here. Okay, yes. In the case of a cuboid, we write length, breadth, and volume, height not are equal. That means the volume of a cuboid, we write length into breadth into height. That's it only. Okay, total surface area, curved surface area, it is other than this. Okay, yes. Now in the case of a cube, length which is equal to breadth which is equal to height. Okay, what I said, length, breadth, height all are equal, then it is cuboid. If not, nothing is equal between them, then it is the cuboid. Okay, so this comes under cone here. Okay, sorry, cube here. If I consider length which is equal to a, breadth which is equal to a, and height which is equal to a, then we write volume. Okay, volume of our cuboid which is a cube. Curved surface area, we have to think only the curved part. Now we can see that, consider this one is our cube. That is the front part, back side part, that one, and horizontal, vertical, all the part. Okay, so we have to think about the curved part. That means only the curved part it is here. Okay, so curved part means 4 times a square. So curved surface area which is a 4 times a square, and total surface area, we have total surface, total number of 6 sides. Okay, area of a top, area of a bottom, 2 sides, front back 2 sides. Okay, total number of 6 sides we have here. So we write total surface area which is a 6 times a square. Okay, that's it for our all the shapes. Okay, yes, I hope you all have understood everything from my lecture. Okay, which I explain all the plane figure and all I explain here, a plane figure and a solid figure. Okay, in the plane we learn here triangle, circle, kite, like a parallelogram, or type of the figures. Okay, and in the case of a solid figure, we learn it here cylinder, cone, sphere, hemisphere, cube, and cuboid. Okay, all these concepts we learn here in our today's lecture. Okay, now let's apply some of the example based on all these concepts. Okay, let's get start our today's lecture with some example. Remember that all the examples are very much important for your SPI exam. Okay, so let's get dive into our today's examples. Okay, now we have to think about volume of hemisphere. Okay, in your SPI exam, remember, you will get the directly formula based question. Okay, what you will get? You will get the directly formula based question in your SPI exam. So what basically you need to do, you have to prepare all the formulas. So sometimes you will get an question, what is the volume of a cube with edges A? Edges is a centimeter. Then you need to understand the formula for cube. Okay, as it is, you have to write the formula for cube. Okay, similarly formula based question, I added that question because similar question I found in your SPI exam. Okay, yes. So volume of hemisphere, we know that. Okay, 2 by 3 pi r square. Okay, 2 by 3 pi r square, which I already explained here. Yes, 2 by 3 pi r square, we learn it here. Okay, about volume of cube. Okay, you all have to understand these all are the formula based question. Okay, volume of hemisphere. Okay, that's it for this question, just a question which is based on the formula. Okay, now next question, what is the area of a semicircle of a radius 5 centimeter? Now see that we need to know in this condition area of a circle. Okay, so what is the area of a circle? Let me write area of a circle which is a pi r square. Okay, area of a circle is a pi r square. Semicircle means half of its circle. Okay, semicircle means half part of the circle. Then area of a semicircle or area of a semi circle, we write 1/2 pi r square. Okay, we write 1/2 pi r square is the area of a semicircle. Okay, now we can see we have radii which is given, radius. What we have here? 5 centimeter. We have radius which is a 5 centimeter. Then substitute the value 1/2 into pi, we write a 3.14. Okay, into radius square means 5 square. Okay, then we write 1/2 into 3.14 into 25. Okay, go for the all calculation, we get the answer. It is 78.57 centimeter. Okay, this one is our required answer which given in on option number first. Okay, so I hope you all have understood this solution. Okay, need to remember the formulas only. Okay, yes, once you come to understand properly formula, then next part it is easier to understand. Okay, now let's move for the next example. Okay, a toy is in the form of a cone. Okay, what we have a toy which is in the form of a cone. So we have given cone here. First of all, plot the figure, visualize it. What we have given? Okay, a cone. Okay, on a hemisphere, cone mounted on a hemisphere. It is mounted inside hemisphere. Okay, now see that this one is the hemisphere, that cone mounted inside the hemisphere, which is a common base. We both have a common base, that means these base are common. Okay, yes, with the radii which is a 7 centimeter, we have radius 7 centimeter, height of a toy 31 centimeter. Okay, height of toy, okay, which is a 31 centimeter. Okay, then we want the total surface area of a toy. Okay, we want the total surface area of our toy here. Okay, yes, first of all understand the example what we have given. We have given radius 77 centimeter and height of a toy which is a 37 centimeter. Okay, so if we are going to take away that radius into that toy, height of a toy, you will get the height of our cone. Okay, yes, so let's find it out, height of our toy here. Okay, yes, okay, so height of a toy we have here 31 centimeter. So if you are going to subtract that 31 from radius, we get the actual height of our cone. Okay, so 31 minus 7, we write it as the 24 centimeter, which is the actual height for our given toy. Okay, which is the actual height for our given toy. Now we do have height, we do have a radius. Now let me write total surface area of our toy, which is the pi r into total surface area of a toy. We write pi r into 2 total surface area. We write pi r into 2r plus l. Okay, pi r into 2r plus l. This one is our total surface area for our given toy. Okay, for our given toy, which is a total surface area, which is a pi r into 2r plus l. Okay, yes, what is the value for pi? We write 22 by 7. Okay, radius we have here 7 centimeter given. What we have? Radius 7 centimeter. Okay, multiplied by 2 times r, 2 times 7 we have here, plus l. Now l we want it here. Okay, and the value for l we have here, which is the, we have to work for the value of l. We don't have the value for l here. Let me find l square, which is equal to r square plus h square. Okay, that means radius square plus height square, we write the l square. Okay, so 49, okay, 7 square, which is a 49. We write it is a radius, which is a 7 square, plus radius square. We write a radius square as the 24 square, okay, which is the let me write directly square for these two terms. I don't have space here. So 24, which is a radius square, and the height square, we write it is the 576, okay, which is the square of this one. And if we take the square root from both sides, we get the L, which is equal to 25. Okay, this one is the our required value for slant height, which is the L. Okay. Yes, then put it here 25. Okay. Okay, this one is the our required calculation. Go for finding all the values, find it out, all the calculation. You will land on 858. Okay, so you will get the answer, your required answer 858. Okay, around 858 or 859, this something answer. Okay, so we write 859. 859. Okay, this one is our total surface area for our toy here. Okay, I hope you all have understood. Little theoretical example, but need to understand what we have given and try to find out the answer. Formula, you just need to understand what is the total surface area of a toy. How I have found here, okay, which is a pi r into under bracket 2r plus L. Okay, lateral surface of area of a sphere already I have explained here. Okay, lateral surface area. Okay. Okay, so lateral surface area of a sphere we learned in our previous slide. Now we can see it here. Let me show all this formula to you all. Okay, lateral surface area of a sphere. Okay, now hemisphere, this one is the sphere. Lateral surface area, we write it is the 4 pi r square. Okay, lateral surface area of a sphere, which is the 4 pi r square. Okay, sphere means lateral surface area and curved surface area both are equal. Okay, in the case of lateral surface area, you will get the what is the curved surface area, which is the 4 pi r square. Okay, which is the lateral or curved surface or total surface area of sphere. Okay, cylinder and cone are of the same base. Okay, we have cylinder and cone. Okay, now see that this one is the cylinder, this one is the cone. Both are having base same. Okay, cylinder and cone both are having base same. Okay, same base radius. Both are having same base radius. Okay, then find the ratio of volume of their cylinder of that cone. Okay, we have to find out the ratio of a volume. Okay, we have to find out the ratio for both of the volume. Okay, now let me write the volume of a cone and volume of a cone and volume of a cylinder. Okay, because we know we need volume of a cone and volume of a cylinder here. Okay, so we know that the volume of a cylinder, volume of a cylinder, we write pi r square h, and volume of a cone, which is equal to 1/3 pi r square h. Okay, this is the volume of a cone and volume of a cylinder. Okay, and we know that we have given height and radius are equal. Okay, what we have? We have height and radius are equal. That means replace height as radius, which equal here height, which is equal to radius. Okay, replace these two condition. Then we write volume of a cylinder. Okay, volume of cylinder, we write pi r cube. Why pi r cube? Because height, which is equal to radius, and r square into r. Okay, when base same, add their power, which is a pi r cube. And volume of a cone, which is a 1/3 pi r cube. Okay, 1/3 pi r cube. And what we want? We want the ratio between both of them. Okay, We want the ratio between both of them. Now what we do, we divide both of them. So pi r cube cancel, 1 divided by 1 by 3, we write this way. Okay, we write 1 divided by 1 by 3. Okay, then we take it's a reciprocal, then we get the 3 by 1. That means 3 as to 1 is our required ratio between cylinder and cone whose height and base both are equal. That's it. Okay, so how easy that question? Similar kind of question you will get it into your SPI exam. Okay, now let's move for the next. Radius of a sphere is a double, then what is the ratio of their surface area? Okay, yes, what we have given in our question, we have radius of a sphere is a double. Okay, we have given radius of a sphere, it is a double, then what is the ratio of their surface area? Okay, now let me write a surface area of a sphere. Surface area of sphere. Okay, so we need to know a surface area of a sphere. Okay, using surface area of a sphere, we have to find out the next condition. Okay, and which is the 4 pi r square. Okay, so which is the 4 pi r square, which is the surface area or total surface area or curved surface or lateral surface area of our sphere here. Okay, yes, and radius of a new sphere, what we have, radius of a sphere is a double. Okay, and when we built a new sphere from our first sphere, we get the radius, it is a double. Okay, and when we have double radius, then we write it as a 2 times r. Okay, so what is the radius of new sphere? Okay, where radius of a new sphere, we write 2 times r. Radius of a old sphere, which is a r centimeter, then radius of a new sphere, we write 2 times r centimeter. Okay, so first of all, understand what we have given. Okay, yes, yes, and then area of a new sphere. Okay, area or volume of a new sphere, we write okay, 4 pi volume of a new sphere. What we get the volume? Let me write volume of new sphere. What is the volume of a new square? 4 pi as it is. Radius, it is a double, that means 2 times r square, r which is replaced by 2r square. Okay, that means 4 pi into 4r square. Okay, this is the volume of a new sphere. Okay, and we want the surface area. Okay, sorry, it is not the volume, it is the surface area of a new sphere. Okay, we are looking for surface area. We are looking for surface area of a new sphere. Okay, now we know that surface area of a old sphere, which is a 4 pi r square, surface area of a new sphere, which is a 4 pi into 4r square. Okay, and we want the ratio between them, then we write the ratio between them 4 pi into 4r square divided by, we have old sphere ratio sphere of a surface area of a old sphere, which is a 4 pi r square. Okay, 4 pi cancel, r square cancel, we get the 4 divided by 1, that means 4 as to 1, which is the required ratio of our surface area for our sphere, which is option number D, which is exactly correct answer. Okay, so I hope you all have understood this solution. Okay, now total surface area of a hemisphere. What is the total surface area of a hemisphere? We learn. Let me know in my comment section. Okay, what we have learned about a hemisphere. Let me know in my comment section what is the total surface area for hemisphere. Okay, this one is the question for you all. Let me know in my comment section. Okay, in our next part, okay, we'll go for the little recap what we have learned so far in our lecture. Okay, so we began our lecture with the basic concept related to the plane figure, solid figure under mensuration. Okay, so under plane figure we saw triangle, circle, different type of the plane figure with respect to area, perimeter, circumference, all these type of the concept. Okay, And in the major part of our today's lecture, what we learn? We learn for solid shapes as a cube, cuboid, cone, cylinder, sphere, hemisphere. Okay, all these concepts we learn in our today's lecture. I'm expecting that you all have understood everything. So if you understood, let me know in my comment section. This one will be the really big motivation for me, you all. Okay, so thank you everyone. Thank you for my today's lecture.